Okay. So what we're doing now is we're talking about, I'm just going to wait till this thing updates here. This part of our lesson is going to be realistic movement. So we talked about sprites, and realistic movement is going to be broken out into this video, as well as next week we're going to do part 2 of realistic movement. And we're going to cover kind of a physics, if you will, for Pygame. So we're going to talk about how we can kind of incorporate a very simple physics-like effect into our games. It's not a true physics engine, and again, what I recommend for you, if you're going to create physics for your game, you may want to look at, especially if you want to make it realistic, PyBox 2D, PyMonk, and so on, or you could use your own calculations, which means you're going to have to do a lot of math and experimentation on your own to make it look realistic. And again, remember, a lot of the physics come from things like friction, gravity obviously is part of physics as well, the kind for game physics anyway. Acceleration, deceleration, all that stuff, and paths. Like the path that an object takes is not a straight line usually. It's modified by the direction and the speed, right? The vector that it's taking, and any kind of gravity, right? So usually when you throw a ball, as an example, and we're going to see this, it's going to take the path is going to be an arc as opposed to a straight line because every frame the ball is going to be pulled down by gravity. Okay? So we're going to understand the basic rule of motion. We're going to talk about firing missiles and all kinds of other stuff. Very basic things. Okay. Next half we're probably going to do following the mouse and all kinds of other stuff we're going to talk about in part 2. Handling orbital physics and so on. Okay. So again, I like this slide because really what it talks about is what games are all about, right? Which is the stuff that we're all interested in. It's about moving around, right? If you're making a 2D game that's static, it's not going to be very fun, right? So we have to kind of understand how physics works, but we don't want to make this a physics course because there's some real complexity you can get into with physics for Pygame and Python, right? So instead of going there, we're going to kind of simplify things a little bit for this course just to give you an idea of what you can do with some basic mathematics. And one of the real strengths of Python is its ability to do mathematics quickly. Python is if you want to talk rapid application development, Python is probably the most rapid you can get, right? I mean, it's a high-level enough language and very easy and object-oriented enough that you can create programs very, very quickly, and really cool programs like we're doing now with our games. Okay, so let's talk about Newton's laws, for example. This is some physics recap, right? Here's one. An object at rest tends to stay at rest. That's a pretty good one, right? That means if you're a couch potato, you're pretty much going to stay a couch potato, right? If you start running outside and you get into that habit, it means you're probably going to keep running every day, right? But the same token is this. If my object, for our game perspective, if it's a box and it's not moving around, right, as an example, it'll stay not moving around unless you apply force to it, okay? And the reason why it stays in one place is because of friction and gravity. Okay, here's another one. Force is equal to mass times acceleration. That's a pretty basic calculation. Force is equal to ma, right? So when you think about mass and acceleration, you have to assign a mass to your objects, right? Whatever the mass is going to be, right? And acceleration, of course, is the rate at which the mass moves faster, okay? Acceleration is a rate. Every action has an equal and opposite reaction. Well, this is a good one because it means that if you collide with another object, you're going to take the force that you're going to impart force or transmit force from one object with mass to another object with mass. And it's going to respond. Both of you are going to bounce off of each other to a certain degree. Depending on which object is more massive, the other object will bounce away from it. Okay? Walls, for example, would be the most massive object, and you'd probably bounce away from walls. You probably wouldn't rip into walls and break through them, typically. So basically, this is the kind of stuff that we want to use when we model motion. Okay, here's some other stuff. Vectors. Okay, another thing to know about vectors, talk about basic math, right? A vector has direction and magnitude, right? We're going to talk about that a little bit. Vector components. We talked about dx and dy values already, right? Because really, we're talking about the change in x and the change in y. I've really been talking about vectors this whole time, right? But now we're going to talk more about vectors in detail. Okay, position. I like this one. This is pretty simple. Position is the x and y coordinate pair of an object, right? In space somewhere, right? Velocity, and this is the thing, the change in your position during a frame, right? So, and it's usually determined as a vector and converted to delta x and delta y components. Okay, and again, this is measured in pixels per frame. Okay, so your velocity in pixels per frame. And the same thing goes with acceleration. A change in your velocity and basically is a change in your delta x or delta y or ddx and ddy coordinates. Right? So again, this is the kind of stuff that that we're going to be talking about. So we're just talking about terminology here, so we all understand what they mean. And I would, if you forgot some high school physics, or if you never took high school physics, there's an opportunity for you to do some research of your own if you're really interested in physics. Even if you did a very quick kind of overview or summary of how these things work, in my opinion, Wikipedia isn't so bad. All right? I mean, it's not 100% accurate in many cases. Wikipedia isn't. I'm not going to tell you that you should use that as the only encyclopedia, but it's definitely cool for some really quick information about how things work. Okay. So here's an example. So motion is a combination of forces, right? Which makes sense, right? And here's an example of a balloon. A balloon has weight pulling it down, right? But the helium, right, that's inside the balloon is lighter than air, right? Helium is much lighter than air as a gas, and so there's a buoyancy, another force pulling it up, right? Winds at a sideways force, right? That kind of pushes it one way or the other, and it, depending on which one is going to win, right? It'll determine where the balloon is going to go, right? So, for example, if you have a wind that's going to the side, the balloon is going to move sideways, all things being equal. But if you have a wind that is going to push down, the balloon is going to go down. If there's another wind that's going to pull up, the balloon is going to go up. If you add more helium to the balloon, it's going to rise. If you take helium away, it's going to fall, and so on. And that's how force kind of works together. Okay. So when you add force vectors, right? So if you have multiple forces working on an object, and one of them could be friction as an example, right? You can kind of add up all the dx and dy values to get a total dx and a total dy to give you the resultant force from all the resultant direction or vector, if you will, from all the different forces that are acting upon an object. Okay, so again, physics in a review. So here's an example. So you've got your force, gravity, right? Your x component, in this particular example, so that means the component that goes side to side, gravity doesn't really affect it. Gravity only affects a component that goes up or down. And remember that if you add 1 to the y-axis, you're actually moving in a downward direction, so towards the ground, right? Buoyancy, as an example, in this particular case, would be -3 for the y component. That means it's going to rise. That's what's going to happen. So the object is actually going to come up. The balloon in this particular case is going to go up, right? Wind, the x component, is going to move your object in this particular example to the right 4 pixels, right? So your results, your total vectors would be 4 to the right and 2 up, because 1 minus 3 is 2, which makes sense, right? So you've got your vector for you got your x direction and your y direction, depending on the forces of an object. And this can happen per frame, so it can create very realistic movement and for your game. Okay. So sometimes what we want to do is we want to have continuous, we want to kind of listen for continuous presses from the keyboard. We don't want to kind of hit the arrow key over and over again, right? And there's a technique we're going to use called hardware polling to do that. We're actually going to listen for the hardware, any kind of key presses, but we're going to do it in a different way than we've done it before. Okay, so let's take a look at turret.py to look at how we can get continuous keyboard input. Okay, and again, we're looking at the lesson 9, archive, right, the code archive right here. So here's turret.py. Okay, and I'm going to analyze this again like we've analyzed things in the past. Okay. So, again, the idea framework, we import and initialize. In this particular case, I think the important thing to note is that we are importing the math library. I think it's important to do that. If we don't have the math library, we can't do advanced math functions. Well, unless you write them yourself, which is kind of silly because it's already been writing and you're reinventing the wheel. Then you have a sprite. We're creating a turret sprite. In this particular case, we're not really kind of accepting any kind of parameters into the constructor, but we are calling the superclass constructor for the sprite itself. We're loading up the turret.gif file. We're converting it into a file that's compatible with Pygame and Python on the show. And this time we are doing a transformation. We're actually doing a different type of transformation here. If you notice, we're doing a scale transformation. We're going scale 2x, so it's going to increase the scale of my sprite by twice. So it's going to double the sprite size, okay? And we're going to, as we load it into from ImageMaster, we're going to take the sprite that we have in ImageMaster, double it, and then load it back into itself. So we're going to make the sprite twice as big, okay? Because the actual turret itself, the sprite for the turret is very small. And then what we're going to do is we're going to put a rectangle around it for the sprite boundaries, right? We're going to put it 320 by 240, which is the dead center of the screen. And we're going to define a turn rate variable of 10. Okay, we're going to talk about what that means in a second. And the initial direction is going to be 0, which again would be east. Okay. In the update, we're going to do two things. We're going to call the check keys method, and we're also going to check the rotate method. Okay. So let's see what check keys looks like. So here's where we're going to start doing the hardware polling we talked about before. We're going to use something else called keys is equal to pygame.key.getPressed. This allows us to do continuous hardware polling, so we can actually hold down the right mouse button, or the right arrow or the left arrow, and it'll continue to get input from the keyboard every frame. So this is kind of key if you're making any kind of video game where you need to get continuous input or turn left or right continuously, or bounce or move or whatever. And we're going to say this: if the keys is the left mouse button, right? Or so the left arrow, I'll be okay. Keep saying mouse button. Then I'm going to, my turn rate is going to be, my direction is going to be plus or equal to my turn rate. And my turn rate, if you notice, as I set it up here as 10. So it's going to be, my direction is going to change by 10 degrees. So it's pretty smooth. It's not perfectly smooth, but it's much smoother than it was before. And it's going to keep doing that until it's greater than 360, and then I'm going to go back to 10 degrees again. It's going to loop. And the same thing for the right. It's going to go, I'm going to subtract my turn rate from my direction. So I'm going to start off easterly. I'm going to go subtract or add my direction depending on the direction I turn my mouse, using this hardware polling methodology here, pygame.key.getPressed. Okay. Then I'm going to call the rotate method inside my update. So rotate is going to say, again, like we did before, it's going to take my old center and transform my object. So again, we're using transformational computation to rotate the image of my turret left or right, okay, based on the number of degrees that I'm turning. Okay, I'm not moving my turret now. All I'm doing is turning it left or right. So I'm not actually creating a vector for turning or moving, if you will. All I'm doing is turning it left and right with continuous hardware polling. Other than that, I just describe a screen. I instantiate my turret here. I drag it into my group. All I'm listening for here now in my event, here's my event loop, right? And in my event loop, all I'm listening for is the quit event, right? Because I do my hardware polling here in my check keys event that I'm checking every frame, okay? So I'm actually, keys is accepting my hardware input. So I'm looking at all keys. So every key that I'm looking for, I'm listening to now, is every keyboard key I'm listening to continuously every frame, as opposed to one frame at a time. If I press my button, I have to keep pressing it over and over again for me to continue getting input. If I hold in the previous examples we've used, if I hold my right arrow or left arrow, I'm only going to get one push, right? It's going to listen for mouse down, right? Or sorry, key down, right? In this particular case, I'm not listening for key down events. I'm listening for get pressed events, which means they're always getting pressed. Okay. And the rest is the same, as we've seen before. Let's take a look at how this works. So again, here's my turret, and this is twice the size of what the turret would look like in fireworks, as an example, because we've used the scale 2x to do it. And now, if you notice, I'm moving right and left. Now, it looks pretty smooth, but I'll tell you, I'm still rotating 10 degrees every time, right? It looks like a pretty fast rotation, right? So here it is. If I change this value, just to make it even smoother, and I say, well, you know what? I want to rotate, but I don't want to rotate 10 degrees. I want to rotate 5 degrees. What's going to happen? Anybody? What would be the effect if I change my the amount of degrees that I'm switching from 10 per frame to 5 per frame? What's going to happen to the mount? What's the effect that it's going to have on my turret? It's going to get slower, right? Because you're having the amount of angle, right? You're having the amount of rotation. Let's take a look and see how that works. It's going to look also a little bit smoother, right? It's a lot slower, but it's also a lot smoother, right? So this is an example of a turret that's rotating left or right, right? And if you notice, I'm getting continuous mouse input from where I can get pretty accurate every 5 degrees, change in angle, right? But it still jumps considerably. It still goes 5 degrees at a time, right? It's not going to be 1 degree at a time. It's not as accurate as that. And if I did that, it would be 5 times slower than this too, right? For the same frame rate. Okay, let me go back and make that 10. So again, we're doing two things here. We're loading an image, scaling it twice, we're transforming it there, right? And we're also transforming it again, rotating it. Every time we do a rotation, left or right, again, depending on what we're going to get with our check keys, we're going to do the transformation twice, right? So in this particular case, because it's a turret, we don't care so much about the size of our bounding box. We don't really care so much because it's a turret, right? It's not going to be hit by anything in this particular example. Okay. So it is much smoother motion than before. And we've kind of gone over this, so I'm not going to go over it again. Okay, here's some neat stuff. So to preserve quality when rotating, load the image into a master image. I agree with that. I think if you preload a lot of your stuff up front, then what you're going to do is just going to make the loading of it a lot smoother than if you were to load it as you go. That's bad. Loading it as you go is a bad thing to do. Okay, we don't do that so far we haven't done that, and we will continue not to do that. Okay? Again, set up a turn rate constant, and it says, like it says, smaller is a slower turn rate, but a lot smoother, right? So you kind of have to find that happy medium. Maybe 10 is too fast and not as smooth, but 5 is too slow, so maybe we're going to go into like a 7 or something like that, or a 6, or whatever makes sense for you. You have to kind of play around with that for yourself when it comes to rotation, smooth rotation. Okay. We've done this already, checking the keyboard, talked about how checking works. So again, this pygame.keyPressed variable, it takes this information, right, which key is being pressed, and stores it in a variable, right? And we're storing it in the keys variable, like we said before, right? So it's kind of saying, well, which key is it? Well, in this particular case, keys is actually a big list. That's what it's doing. It's saying, if hardware polling works to say, I've got a bunch of key presses all the time. It's not one. And all I'm doing is I'm appending my key presses to my list of presses, right? So I can actually look at both keys at the same time, or multiple keys being pressed at once, and it's going to try and get all those keys and put it into a list. Okay, and if you want to see how that works, let's run this program again. And what if I was to press both buttons at once, right? It's going to try and take whichever button they can read first. If I hit both buttons, it's not going to move right or left because both buttons are going to kind of countermand each other, right? I'm hitting both buttons at once, left arrow and right arrow, right? If I hit a space bar, because I haven't listened for it, it's not doing anything, right? Okay. Rotating the turret. Again, we talked about this transformation. And normally, like I said, I don't recommend doing these kinds of transforms within the code because what ends up happening is when you transform in the code, your object, you might lose pixel clarity. It might not look right. Your shadows are going to change. All that kind of stuff is different. So I recommend when you do rotations, if you can, to use different images. So flip images. That's more accurate than if you're actually transforming the object. But sometimes transformation makes sense because it's the cheaper thing to do. It's the easiest thing to do. And sometimes we want to be fast and dirty when we program. And what I mean by that is it takes too much effort. There might be too many images that you have to go through. And there's an economy here that you won't see a big difference between loading a bunch of images for turrets that are in different angles, as an example, unless there's, like I said, you have this other, you want to preserve the shadow of the turret. Okay, we talked about building the main loop. It's exactly like before. Okay. So last time we talked about, when we did animation, we talked about kind of looking at 8 directions. And the question we have from every time is, what if you want to go in any direction you want, and any speed you want, right? How do we calculate the vector there? Well, this is called vector projection, and we're going to have to kind of figure out where you're going to move before you actually move, right? So we calculate the vector before you actually get there. Okay? So here's how it works. All right? So you have your starting orientation. Let's say, for example, your starting orientation is east, right? Then you have your theta value, or your angle, right? And math, theta value, and the angle of rotation, if you will. And then you've got your distance, which is what we call r, or radius, away from your theta value, right? So it's kind of looking at the problem itself. How do we fix this problem? Well, again, we can do it in dx and dy values, right? So we want to kind of get a result of dx and dy. And again, dx and dy, if you look at it, is still Pythagoras, right? Dx squared plus dy squared is, you get your actual vector of r is actually r squared. So you want to get the square root of r squared, as the vector. And every time we move, we build these triangles to create the vector with the resultant vector. Okay? And again, using trig terms, opposite over adjacent, or opposite over hypotenuse, and so on. Those are the things that we're going to be using when we calculate things. So here's an example, solving for dx and dy, right? Dx is equal to r, so the vector, the length of the radius, times cosine of theta. Right? Now, do you guys have to remember this stuff? Do I expect you to remember math? The answer is no. And I think there's lots of stuff out there that you can pull into your code. This is where economy of programming comes in. If it's already done out there for you, don't redo it, right? So you're going to be handed code that does a lot of this calculation for you, right? So and this is where you have dy and dx. So here's dy, which is r sine theta, and this is dx, which is r sine theta, r cos theta, right? R cos, like the robot. Okay, and again, the result is going to be in pi radians, right? So 0 would be 2 pi, and so on. You're going to get that result, and you're going to translate that into degrees. Okay? So we're going to take this piece of code called vecproj.py, and that piece of code we're going to use when we do our vector calculations when it comes to movements. Let's take a look at vecproj.py, which is going to be right here. So it's a little piece of code. Here it is, and this is we're going to use the console to print out some angle and distance. So here's an example. Okay, so it says, give me an angle and distance, and I'll convert to dx and dy. Right, that's what it's actually saying. Okay, so the distance, I want it to go, let's say, for example, 100 pixels, right? And the angle, I want it to be 30 degrees, right? So it's going to say, well, my dx should be 86 point blah blah blah. My dy should be minus 50. Right? So it does all the calculations for you, and it's right in here in the code, right? So you don't have to figure out r times math, theta, and so on. All it's going to say is, what's the angle you want, and then, what's the distance, r is the distance, and you're going to get your dx and dy values from that. So if I want to move 100 pixels, and I want to go at this particular angle, it's going to give me the dx and dy values automatically, as opposed to you trying to figure it out and and trying to convert it to the angles and so on from pi radians and so on. Okay? So we're going to use this method inside of our calculations in other code. And it's part of your archive, so you don't have to look around for it on the internet. Okay? Okay. And I'm not going to go over vecproj.py because we're not a math class, right? We're going to use vecproj.py to provide dx and dy values. Okay? And you can look at that on your own time. But let's take a look at turretfire.py, which is really what we want to look at. We want to get that vector projection, and we want to be able to fire a bullet from the turret, right? And we're going to talk about some methodology about how to do that bullet firing stuff. Okay, so let's take a look at this code a little bit. We have a label in this particular code this time. Again, we're initialize. We import math and Pygame. And we have a label Sprite. It's a subclass of the Sprite superclass. And what we're going to be doing here is I'm going to have my constructor here. I'm going to use the constructor from the Sprite class. And we're going to define a font with a 30 pixel height. It's going to be in the center of my screen, 320 by 240. That's where it's going to start off. And the text is going to be blank in the beginning. So the font, the actual text for the label is going to be empty, and the font is going to be our standard default. And then what we're going to do is we're going to say, we're going to render the font on the screen with the text that we have that's in there. That the originally it's going to be empty, blank text, okay, on update. So whatever the text is going to change to, we're going to render on the screen, in the middle of the screen, and it's going to be black. 000 is the color of the text, right? Everything turned off, so it's black. Okay, we're going to actually update the center as well. Okay, then we have our turret, exactly like we had before, except now we have a couple of extra other variables. One is shell. We have a shell variable, okay? And we're going to get the shell passed into the constructor of the turret class, right? That's the first thing we're asking for. So before we get into turret, let's take a look at shell. What is shell? Well, shell is going to really be another sprite. So we're actually getting a reference to this other sprite inside the turret class. Okay, this is the challenge. The shell class itself is going to get a reference to a surface object. We're calling it screen here in the class itself, right? We're defining a surface of 10 by 10. So our shell is going to be 10 pixels by 10 pixels, a square of 10 by 10, right? We're going to fill it with what looks like to me 0, right? So it's going to be black as a background, if I'm not wrong. Or it might be white. I'm not sure if the background is white or not. Let me take a look. Yeah. Okay, it's going to be transparent anyway. And then we're going to set our color key to the background of the object. We're going to draw a circle, right? And we're going to fill that circle with black. Okay? We're also going to make it a radius of 5. And we're going to start it's going to be actually inside the middle of our circle, of our sprite object itself. We're also going to scale it in this particular chance, in case, whatever. But it's going to be, we're going to take our image of our circle itself, right, and we're going to scale it and put it back inside the image's variable itself. Okay. Now, if you notice what the scale does, if you want to know what that does, you say the width and the height of the object, right, is what we're really looking at. Okay. And then plus the destination surface. Okay. In this particular case, it's equal to none. Right. So the height and the width of the object. So self.image, right, itself is the height, and the width is the stuff that's going to change. Okay, height and the width. Okay, and here what we're going to be doing is we're going to rebound the box of the shell. So we're saying transform the shell into a small object, right? And we're going to set this is the interesting part about the shell itself. Okay, we're going to set the center of the shell outside of the viewable area of the screen. So why would we do that? For those people who are watching here live, as opposed to be on video, why would I make the shell, or if I make a bullet, why would I put it off the screen? Why would I do that? initially. So I create my shell, and it's off the screen somewhere. Why? Anybody? Well, because if I show my bullet, and if it's on the screen, it's going to kind of look funny, right? I'm going to have a bullet over here on some part of the screen, and then all of a sudden, when I fire my bullet, it's going to move, right? It's going to change position, right? And I want the bullet to kind of be invisible anyway. I only want the bullets to appear when they come on the screen, right? In this particular case, it's going to start in an area of -100, -100 off the screen, but you cannot non-visible. Yeah.
Would you create a separate class for a bullet and then just create the method?
That's what this is. Here's your separate class right here for the bullet, right? You can create a mess of them. Like you said, you can create, a whole array of bullets, 20 bullets or 10 bullets for the gun, whatever you want to have. But the reason why you want to preload them, pre-create them, and pre-display them off the screen as opposed to create the bullet later on is because it takes more horsepower for it to do it. You might have a slowdown on certain systems. So you create all your objects and you display them, but you display these bullets off the screen somewhere so they're ready to be fired from you. You can't see them. The player will never see them, right? Okay. And you set a speed of 0, the direction of 0, and what you want to do is you also kind of call this reset function. And the reset function moves everything back, the bullet itself. It resets the bullet to -100, -100, and sets it to 0. So initially, whenever this thing is, you move it off the stage or the canvas so you can't see the bullet anymore, right? And it has a speed of 0, so the bullet's not moving, it's just sitting there. Okay, that's what this thing does. So we create the bullet itself, it's a certain size, moves off the stage. On the update, you're going to do a bunch of stuff. You're going to call the calc vector function for the bullet itself, where it's exactly the code that we got from that calc vector program that we looked at. It's going to do all your calculations for you. It's going to give you the resultant dx and dy values, right? It's also going to say this. It's going to say whatever your resultant value, multiply it by -1. Right? So whatever, it's times equal to -1. So it means it's going to reflect the value depending on what your dy value is at the beginning. Okay? We're going to talk about this little line here in a second, what this means. Okay? And again, so you calculate your dx and dy values depending on the direction you need to go. You're going to calculate a position, and the position is going to be your you're going to add your dx and dy values to your x and y, right? And then what you're going to do is you're going to check bounds. So you see if your bullet goes off the screen, you want to reset it. You want to put it back into its original home position and set it to motion to 0, right? So it's going to go, and as soon as it's off the screen, it's going to reset itself to that other position, that phantom position off screen that you can't see. Okay? Once it leaves the viewable area. Okay? So that's really your bullet. So you're taking that bullet and you're putting it into this Sprite, this turret class. So it's actually going to know about this shell. It's going to get this new Sprite. The class turret is actually going to understand it needs to have a bullet class that goes into it as input. Okay? That's the first thing it needs. So it's getting this bullet and it's assigning it, or by reference, to another variable called self.shell that's going to reference throughout the code, right? And then what we're going to do is we're going to load up the turret, do the exact same thing we did before, scale it twice the size that it was before, and that's a really weird interruption, and move it into 320 by 240 in the middle of the screen. Define a turn rate of 10 like we did before, and we're also going to say a charge of 5. The charge is really going to be how much energy, or if you want to call muzzle velocity, that we're going to add to our bullet. The bigger the charge that we're going to define here, the faster the bullet's going to start to move. Right now, the charge for the bullet is going to be 5. It's not how many bullets, it's just how fast it's going to move coming out of the muzzle. Okay? And then what we're going to do is we're going to say check keys. We're going to use that hardware polling method that we used before for left and right, right? We're also going to look at up and down, right? We're going to talk about what this up and down thing does, right? This actually increases our charge, the speed of the bullet coming out of our gun, our turret, and it can increase it or decrease it up to 20 and as low as 5. So it can't go lower than 5 for our charge, and it can't go higher than 20 for the speed or the power of our gun. Okay? Then we're going to also listen to space. So every time the space bar is pressed, that is when the bullet is going to come out. And as I press my space bar, and this is where the bad stuff happens, and I want you to see the effect when we do this, right? Your center X and center Y for the shell changes, right? Here's the shell. It changes according to, the direction and the distance, right? It actually reassigns it to the center X and center Y value that is back up here. Center X and center Y start off at 0, right? Or the direction, the location of my turret, right? That's where center X and center Y is, right? Which is bad, right? This is a bad thing. If my turret, if my gun, my bullet, tell me what the effect is going to be, guys. Can you predict it here? So here it is. I've got my space bar and my shell. I bring it onto the screen, and when I press the space bar, it starts off in where my turret is. What's bad about this? Every time I press the space bar. And if I hold the space bar down, it's going to keep doing that. It's going to resetting it back to where my cannon is. It's going to make the bullet disappear. So every time you press the space bar, it's going to start going, and then when you press the space bar again, it's going to reset the bullet back to its original location. So this is the challenge. The way this works is it allows only one bullet to be on the screen at once, right? Which is a challenge. You have to figure out how to make more than one bullet come out, right? So what you want to do is create an array of bullets, like 10. And what you want to do is you say, every time I press the space bar, I want to have one bullet, 2 bullet, 3. And if my bullet is in flight, you got to create some kind of a flag that says, well, if my bullet's in flight, as an example, I can't press the space bar again. Don't listen to the space bar until my bullet leaves the screen, until my bullet has been reset. Okay? And if my bullet's in the reset position, then I can fire again. Otherwise, you're going to get this weird effect where every time you press the space bar, it's going to reset back to where it was, and it's going to look really ugly. And you're only going to have one bullet. So you don't want that kind of bullet firing. You want to change it. And that's going to be one of our exercise for today. I'm going to actually to get you to do with using the turret.fire program. I want you to make multiple bullets fire. Modify this code within about 20 minutes to make this fire multiple bullets. We'll talk about how to do that. So the rotation, when we rotate, we're going to transform the object, right? And wherever we transform the object, we're going to rotate according to whether we move left or right. The angle, right? Here, the direction, 0 and 360 and so on, is the angle that we're going to use also for where the bullet starts to go. Okay, so once I press, I go left or right, I'm going to use the direction, right? And I'm going to set the direction of my shell, right, to the direction of my turret. So here it is right here. So my turret's direction and my shell's direction is going to be the exact same. When I start aiming my turret, I'm going to move my shell to wherever I'm aiming. Okay, that's what I'm doing. Okay, which is what what you do when you have a gun, right? The rest is pretty much the same. If I go back down here, except this time I do a couple things. I instantiate a shell, a turret, a label output, which is a label, and I want to define my label center as 120 on the screen. That's where my label is going to be. I'm going to actually move it into the place I want. I'm going to group them, my shell, my turret, and my label output, so that every update, every frame, I'm going to update them. And my label is going to actually contain, in the update, the text of my direction and my speed from my turret. Right? Before I fire my gun, I can change my charge, or the speed of my bullet, right, and the direction that it's pointing in. Let's take a look at how this works. So here's my turret fire. Okay, and I'm going to fire a shell. So first thing I do is I change my direction. So here it is. If you notice, I'm at 150. My angle is 150. If I press it again, it's 160. If I press it again, if I try to press it one step at a time, it goes up by 10 at a time. If I keep going, it's going to look like it's moving very, very quickly. But again, it's shifting 10 degrees every time I move I press my left and right keys. Right now, my speed of my bullet is 5. So when I fire it, it kind of goes at 5 pixels per frame. Right? So here it is, 5 pixels per frame. Here's the problem. What problem do you see here, guys? Take a look. Here's the bullet. You see it? Why the hell is my bullet on top of my turret? That's an issue. Well, again, it comes down to layering, right? And we can do that. We can fix this problem with layered updates, right? Or ordered updates. So this is the first problem we're going to fix. So instead of using group, right? Group is the wrong thing. We want to use ordered updates, right? So we want to change that class to ordered updates because ordered updates allows us to say, depending on how we load this up, shell is first, then on top of that is turret, then label output. Right? That's the way we want to do it. So now let's take a look at it. So that's the first fix we made, right? So here's my turret. I move it around and I press my button, and now my shell fires from my muzzle. It doesn't fire from my on top of my doesn't appear on top of my head, kind of thing, like on top of the turret, right? Which makes no sense. Doesn't look realistic. And if you notice, the charge is only 5. If I increase my charge to 20, right, so faster moving shell, there it goes. But if I press the button twice, right, or I keep pressing my space bar, it makes the shell disappear. And this is what I want you guys to fix, all right, in your exercise for today, all right? I want you to change it so I can fire multiple shells, and it's not going to reset my shell back to the center of my turret, okay? So I want to be able to fire, let's say, 10 shots, or a few shots. Let's say 3 shots. And then when my shell is in flight, and if I'm out of rounds, right? So I got to wait to reload, as an example. I want you to wait until my shells are off screen before I can fire again. Okay? So there's reasons for this, because you're going to encounter the same thing. If you use this code, which you have, I mean, it's part of your code archive, to start adding bullets to your avatars to fire stuff at, you won't be able to. It won't run properly because you're going to get, every time I press the space bar and I press it again in mid-flight like this, I'm going to get my bullet disappearing. I don't want that. That's a crappy thing to happen, right? So I want you to fix it.
One every bullet.
What was that?
One every bullet count.
Every bullet has to count. Yeah. There's different ways of doing things, right? There's different approach to this problem. Okay. Yeah. What? Okay, we'll be there after this. Let me just get through the presentation. All right. So we talked about this turret fire. I'm not going to go into it again. We just talked about all in detail how the turret works and what the charge means here. The charge is basically we're accepting the shell into the constructor. So we're actually passing another object into our class, and we're modifying that object. Right? So the turret actually has the shell class that's passed into it, or the shell object. Now, here's an interesting thing. If I want to have multiple shells, right, I don't have to receive just one shell. I can receive an array of shells. Or I can take a shell, right, I can call the shell class instead of for it being passed into the turret. Another approach would be I can call the shell class inside my turret class, and I can instantiate a bunch more objects. Okay, there's different ways of doing it. But the better way to do it would be instantiate the objects I want. So if I want 10 bullets, I instantiate them first, and then I pass them into my turret. So I pass them into my turret as a list of sprites. So I've got, let's say, 10 bullets, and there are bullets that are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now when I hit the space bar the first time, it's going to fire the bullets. And you may want to create a delay. So for example, even if I press my space bar and I'm continuously pressing it, maybe I only want to launch a bullet every other frame or every third frame, because maybe my gun isn't like a machine gun where I'm spitting out one bullet per frame. So you're going to have a bunch of bullets spit out all at the same time, one after the other, right? And maybe you want to create that delay. So there's some hints on how to do that. Okay, the check keys method we talked about before, how we change the charge, and the charge is really the speed of the bullet, how much energy that we're giving the bullet itself. Okay? Okay. And when we fire the shell, we're setting the position equal to the turret's position, but we keep doing that, and that's kind of a problem. It presents a problem for us firing multiple bullets. Okay? The shell class. And again, we talked about this, we kind of move it off stage, and I recommend that you move all objects off stage that you're going to use later on in the game. So let's say, for example, your character, your avatar, is going to use a sword, some kind of object, power-up that you're going to give your character, right? And he's going to hold it in his hand or something. There's two approaches to this problem. One of them is the sword is actually a new sprite. So when your avatar picks up your sword, now you're going to show the avatar with sword sprite object as opposed to the avatar without sword, right? Or the sword is actually something that you can have physically pivoting on the avatar's hand, right, as an example, and it's an actual sprite of its own, right? So there's different approaches. And there's also complications involved in these two different approaches that I'm talking about. Okay. So again, we're using that calc vector methodology that we got in that calc vector program to define the angle. We get the angle, and then from the angle, what we're doing is we're calculating the dx and dy, right? Now, the reason why we invert the dy, like I talked to you before, is we want to compensate for y increasing downward. So if it's increasing downward, right, if we want to fire up, we want to fire in the direction that we're moving as opposed to, if we don't do this, then it'll give us a weird effect, right? It'll always fire down as opposed to up. Okay. Again, resetting the shell, this is a key, resetting it back to -100, -100, and 0, right, whenever we go off the stage. Okay? Another thing we might want to do here, again, is when we reset this, maybe in here, if you're going to be doing this little exercise for today, and for those of you who are watching the video, try this. Here is maybe where you want to put in the flag that says this bullet, whatever the bullet is in flight. You want to kind of set up that variable. So this bullet's in flight, it's being used, right? So as long as my bullet's being used, I can't call the bullet and reset it. Okay, I can't reset the bullet unless if it's in flight, right? Because it doesn't make any sense. If I fire the gun, I can't say, I want to take it back. I don't want to have that bullet hit you, guy. I want to take, you can't do that, right? And in this particular case, they create all three sprites: the shell, the turret, and the label. And that's fine. We update the label in the main loop to show the speed and direction. Okay. One more, and then we're gonna pause for some time for you to do your exercise. Okay. So this is cool, right? That you have this ability for you to turn and fire your turret. But what if you want your turret to follow your mouse position, right? So wherever I move my mouse, I want it to be exact. So whatever angle, wherever I put my mouse, I want the turret to follow me, okay? There's some really cool things you can do with this, and I would ask you to take a look closely at this code and what I'm going to talk about now, because it can define the heart of your AI as you move forward. This stuff right here. And we'll talk about how it does that. Okay? So let's look at followMouse.py. So moving away from turret fire. So here's your followMouse program. Again, we're doing a couple things now. We're actually importing the turret fire program, right? So when we do this, just for those people who are watching here live, what do we do when we import a program, turret fire? What am I doing, right? I don't care about the main, right? Main is gone because I'm using this methodology we've been following since the beginning of our course, which is if name is equal to main, then use our main. Don't use the main from turret fire, right? Turret fire there's a couple of really cool classes, right? It has the turret class that we're going to call on, and it has the bullet class, our shell class we're going to call on as well. So we don't have to redefine that or rewrite them in here, right? So turret fire, okay? Here we're actually defining our turret class yet again, right? Here's our turret class, and even though we have turret fire already, right? But if you notice, we don't have shell in here. So actually we're redefining our class, our turret class here. We don't have to do this, but there's going to be some changes that we're going to use in our turret class. So we're going to overwrite what they were before. We could actually inherit our new turret from our original turret class. But in this particular case, the authors decided to rewrite the turret class altogether. He's not talking about inheritance here. Okay, but you could inherit it and create a subclass of the turret class that has some other differences. For example, the update method would be different, right, in our new turret class. And the follow mouse method would be there, right, that allows us to follow the mouse instead of using the keys. Now you could do both if you actually inherited the class. We'd have both methods. And maybe that's why the author didn't want to include those other methodologies here. But let's take a look at this class. So again, we create a turret. We scale it twice as big as it was. We set it in the middle of our screen, 320 by 240. But in this case, we're going to use it to follow the mouse. How do we do that? Well, our dx and dy values are going to be equal to our mouse x and mouse y position. Okay, that's interesting, right? Because we're going to get our mouse position from this get position, mouse.getPosition method, right? So now, instead of it calculating our angle the other way, right, our calc vector, we know where our dx and dy values are, and now what we want to get is our direction. We want to extrapolate our direction from our dx and dy values, and we can do that by using arctangent, right, to get our radiance or our angle. Okay, so let's picture this. So wherever I put my mouse, I'm going to get the dx and dy value and the angle that I'm at between my mouse and my turret. Why would that be really cool for AI? Think about this, guys. Okay? I've got my position of my mouse, right? And I've got the angle, and I've got my dx and dy values. Well, guess what? My turret now can see my mouse. So think about this like this. If you have your turret follow your avatar, wherever it is, it's almost as if it can see the avatar is there. It'll actually move the angle. It'll try and fire at your avatar perfectly every time, right? This is the way you can do that. Now, there's things you can do to block line of sight and so on. We can talk about line of sight a little later. Okay. And then it'll rotate it the exact same way. The only difference here, this follow mouse procedure calculates the direction and the dx and dy value according to your mouse. The distance, of course, also is calculated differently. It's equal to the square root of dx times dx and dy times dy, right? X squared plus y squared is equal to the distance, right? The square root of the distance. All right. Also, this label distance is going to be added in, right? This is a new class that we're defining. This label is going to be basically talking about the angle and the distance from the turret. That's what it's going to do, and it's going to get that. Here it is. Our self-text is going to be equal to the turret direction and the turret distance. Okay, that's what it's going to do. So it's going to actually access this turret class, and it's going to actually take a turret object as one of its parameters in the constructor. Okay, 640 by 480. Again, the screen, it's going to be filled up with a particular color. It looks like it's going to be a type of green, and we're going to blit it to the background. We're going to create a turret. Right here's a turret. We're going to create a label of this, a distance label, and we're going to group them in the turret and the label inside of our sprite group. Okay, so let's take a look at how that works. So here we are, and it crashes. I love it. It says turret object has no attribute distance. Well, let's take a look at that. So here's our turret object, right? And it has no attribute distance. What's that?
See it there.
Where?
Oh wait, no, that's the follow mouse.
This is this turret here. It says self.distance is in follow mouse, right? So this is the problem, because follow mouse, right, is not equal to anything, right? So what you want to probably do is do one of these, right? So self.distance is equal to 0, right? And then once you've done that, what you're doing actually, you're saying this one here, self.distance, is going to be equal to this one. Now that'll fix it. Let's try it. All right, here's our turret. And if you notice, here's my mouse. Take a look, guys, for those of you guys here, please. So here I am. It's figuring out how far I am and where my mouse is. It's going to follow me exactly the angle of wherever my mouse is. So Imagine you're making, again, you have your my mouse is actually my avatar, right? And the turret's actually firing at me automatically. It's going to fire at my avatar automatically depending on where it is. Hence, AI. Right? So my artificial intelligence for this could be my enemy. The turret could be an enemy turret. And it's mounted and it's looking at me, right, wherever my mouse is. Well, imagine if you had more than one turret. I defined a turret and it's looking at my mouse, right? This turret is pointed at, is positioned here in the middle of the screen, right? But what if, and I love doing this kind of stuff, right? Instead of having one turret, I have two, right? So here's my other turret, turret number 2, right? I like this, but the problem with this type of turret is my position, the position of my turret, so this is my, here, my self.rec center, the center of my turret, right, as an example, it's 320 by 240. It's always going to be 320 by 240, right? So that's a problem, isn't it? So what I want to try and do, instead of doing this, is I want to define another value. So I can do this, self.center, right, is equal to self.rec.center. Right, that's the cheap way to do it. There's other ways too. I could also pass it into the constructor. But now I've got the center property, right, that I could assign, right? And what I want to do, or I could actually say self.rec.center is equal to whatever, right? This center value is the one that I want to use instead of my rec center for my 320 by 240, right? When I'm defining the position. So when I actually update, and here I am, I want to update the center of my position to this rec center, right? So here on my update, I'm going to say when I put the position out here, I want to actually get the position of my center from there. I could do that, or which I think is better, I want to pass into the constructor just like we did last time. Here's my constructor. I want to pass in a center, right? So here's my center. And this time I want to say this. Well, my center is actually going to be a tuple, right? So self.center, in this particular case, is equal to center. I'm going to add that in there. And I'm also going to define a default, just in case the person decides not to enter anything. I'm going to define a default of 320 by 240, right? Now, I don't need this anymore, right? I don't need this value here. Let's get rid of that. And instead of this being 320 by 240, right, I'm going to assign this to make it self.center, right? So once I've done that, now I have flexibility with my turret. I can assign it anywhere I want, right? Okay, now I've done that. Now I'm actually going to assign some different values to my turret. So here I've defined my turret as having possible values or not. And here I'm going to assign, instead of 320 by 240, I'm going to go 120 by 240. So I'm going to have another turret, right? A 120 by 240, right? Now if I do it right, by the way, it has to be a tuple. Otherwise, it won't understand what that is, right? Here's 120 by 240. If I actually define this properly, and if it works right, and I didn't do it. I didn't actually instantiate both. I didn't actually pass them both to my group. See, I'm getting so excited. I didn't pass both of them to my groups. Here it is. Here's my second turret, turret 2. And now I'm actually going to define both of those objects. It was instantiated, it just wasn't displayed. All right, 2 turrets. And now they're both looking at me. Take a look, guys. They're both independently looking at me, right? Depending on where my mouse is, they're going to try and fire at me, and they're going to adjust automatically, right? Depending on where it is, they're going to create distances. They're going to have values and distances to fire me. I can have 3 turrets. Here's another one. Let's define the third turret. Turret 3 is equal to turret. And instead of 120 by 240, I'm going to go 30 by 30. Right? Top left corner of my screen. And again, I'll put it inside. If I don't put it inside my group, then it won't appear. So here's turret 3, and you can see where I'm going with this. Right? You can have multiple enemies, and they're all different positions. And depending on where my mouse is, my avatar is, they're going to fire at me all together all at once. Right? So again, this is a great opportunity for you to create enemies that fire bullets at you. and they can follow you, so almost a type of AI, right? And again, you can create rules about, is my avatar, and this doesn't have to be your mouse, it could be anything. It could be the X and Y coordinates of your other sprite, your avatar, that you move around the screen, right? So again, I have my mouse moving around there, all these turrets are looking at it all at the same time, trying to find it. Or, what if, and here's the thing you can't do, that there is no line of sight between my avatar and my turret, right? So then stop following me, right? So in other words, I can put, if I can put a wall in front of my line of sight, if my avatar is behind a wall, the turret doesn't know where I am. It only knows my last position, so it'll stop where my last position was. Or maybe you can make it so it scans. It's kind of looking around, like other turrets do, right? And as soon as it sees me, it kind of beads on me. You could also make it so that the turret doesn't automatically switch to your position, but you give it a bit of a delay. So it's coming towards you, like looking towards you because it knows where you are, and it's trying to follow you and fire at you at a certain rate of fire, right? And so you can create smarter or dumber AIs. Okay? Ways of doing it. I encourage you to look into this method. I think it's worthy of your attention. Okay, and I'll just set this back to where it was before, just because I'm that kind of guy. And I want to be able to do that with the other class. All right. Here we are. So follow mouse. That's a key one for those people who are watching. Now let's take a look at the program just really quickly before we finish. We only have a few slides left. Again, it calculates the components. It takes the components, it converts them back to vectors, and it does this through this tangent, an arctangent formula or functions that we have in math, right? We modify the turret class, but again, we didn't modify the turret class. The class actually has been rewritten because I've rewritten my turret class. I didn't make a subclass. In this case, all I'm using from the original turret fire library that I created was my bullet, my shell. Otherwise, the other turret class I've thrown out. I could have done a subclass of the original turret class, but then I would have had the other methods that maybe I don't want to have, where I can move my turret with my my keys as opposed to just with my mouse. Okay. And we used arctangent again, this function to change the the dx and dy values back into degrees and rotate the turret accordingly. Okay, that's all done there. We already talked about that, how the mouse works. And that's it for today's lesson. So again, what I want to try and do is we're going to go into our exercise now. So for those people who are watching, next week we'll continue with realistic movement and gravity effects and so on. So stay tuned.